These are notes for Unit 2, Introducing Proportional Relationships, and this is Lesson 3, more about constant of proportionality. And in this first activity, they go through a series of conversions or changes from one unit to another. So from centimeters to meters, or meters to centimeters, hours and minutes, and feet and inches. So this is not so much a calculation, but more a recognition of what's the relationship between these two units. If we actually do the calculation, then that's called converting or changing from one unit to another, or converting from one unit to another. And I set a little bit of this up in terms of y and x, because that's going to be the constant of proportionality, y over x. Eventually we're going to look at that a lot. That's the constant of proportionality, so meters to centimeters, minutes to hours, feet to inches. But that's not the emphasis of this activity, so don't get carried away with going into these details too much. I'll show you a little bit of that. So I broke this up into 3 parts, centimeters and meters first. So the relationship between centimeters and meters, for me, it's easiest to think about what's the tiny thing, in this case centimeters, and what's the large thing, in this case meters. You need more centimeters, so we're changing from the number of units, not the size, but the number of units. So you need 100 centimeters, 100 of these little things, to equal one of these big things. So if you want to figure out the number of meters, you're going to multiply by the number of centimeters by 1/100th, because you're going to make that number smaller. So the number of meters is 1/100th the number of centimeters, or times the centimeters. So for example, the number of meters is 1/100th 40 centimeters. So 40 centimeters is 4/10 of a meter. Again, not so much to do this calculation, but just to recognize it. See if you can look at these numbers and recognize the relationship of 1 to 100. And you can go the other way. If you want to figure out the number of centimeters, that's 100 times the number of meters. So a few big things, 4/10 of a big thing, is a whole lot of the little things, 40 centimeters. So the relationships up here, 1 to 100th. So 1 centimeter is 1/100th of a meter. 40 centimeters is 4/10 of a meter. 50 centimeters is 1/2 of a meter, or 5/10 of a meter. And 30 centimeters is 3/10 of a meter. So those relationships of 1 to 100, or 100 to 1. And here's a little calculation of multiplying by powers of 10. So 4/10 times 100 is 400 divided by 10. So down here, 4/10 times 100 is equal to 40. So how do digits move when you multiply by 10 or 100? Again, just lots of stuff going on in these activities, and it's a question of what to emphasize. But in this case, in the simplest form, just emphasize the relationship of 1 to 100. And here are the answers that they come up with. 1 centimeter, 100th of a meter. 30 centimeters, 3/10 of a meter. 40 centimeters, 4/10 of a meter. And 1/2 of a meter is 50 centimeters, or 50 centimeters to 5/10 of a meter, if you want to change that to 5/10. All right. Hours to minutes. Again, the big thing is the hours. The little thing is the minutes. So you need a lot of minutes to equal 1 hour. One of the big things, you need 60 minutes to equal 1 hour. So if you want to figure out the number of minutes, y is going to equal 60 times the number of hours. So if I have 1 hour, 60 times 1 hour, 60 times 1 is going to equal 60 minutes. So recognizing that relationship of 1 to 60. So 1/5 of an hour, if you want to figure out the number of minutes, you multiply by 60. So 1/5 of 60, 60 divided by 5 is 12 minutes. And so this one's interesting because they don't give you 2/5, but they do give you 4/10. And so you might recognize that 4/10 is the same as 2/5. And if it's 2/5, that's twice as much. That's of 1/5. Well, what's 2 times 12 minutes? 2 times 12 minutes is 24 minutes. So 2/5 of an hour, or 4/10 of an hour is 24 minutes. Again, you can multiply it by 60, but it's that recognition, that fraction of 60. So 1/2 of an hour is 30 minutes. And I think that might be at 1/5 of an hour. 2/5 of an hour is the 24 minutes, or 4/10 of an hour is the 24 minutes. And 1 hour is certainly 60 minutes. I think that's all of them. So the answers that they come up with: 1/2 of an hour is 30 minutes, 1 hour is 60 minutes, 1/5 of an hour is 12 minutes, and here's the 4/10 of an hour, and their answer has 24/60, but it's really just 24 minutes. And so this 4/10 is the same as 2/5, which is twice as much as this 1/5. And finally, feet to inches. So you need a lot of inches to equal 1 foot. So the big thing is the foot, the small thing is the inches. You need a lot of them. So if you want to figure out the number of feet you have given a certain number of inches, it's 1/12 the number of inches. So y is equal to 1/12 whatever number of inches you have. So in this case, I'm saying that the x value is the number of inches. And if we go back, we just looked at these two are not in the answers, but I thought they were interesting. 1/5 of 60 inches, we just did that when we looked at the hours and minutes. 1/5 of 60 is 12. Well, that's 1 foot. So you could use the 1/5 and you could use the 60. 1/5 of 60 is equal to 12 inches, which is the same as 1 foot. And they're not looking for that, but that one's kind of interesting to think about. Well, if that's true, then 2/5 of 60 is 24 inches, because twice as much. 2 times 12 is 24. So if you take 60 divided by 5, that's 12. 2 times 12 is 24. And they do have 24 inches is equal to 2 feet in the answer. Again, you can get the 4/10 in there because that's equal to 2/5. And finally, the 30, they don't use the 30 either, but 30 inches, 30 is 1/2 of 60. So 30 inches is how many feet? Well, 30 inches is going to equal, 1/5 of 30 is going to equal 1/2 of a foot. It's going to equal 6 inches. So it's half of 60 is 30. 1/5 of half of that is going to equal 6, or 1/2 of a foot. I'm getting going a little bit overboard here, but 2/5 of 60 is 2/5 of, if you take half of that, what's 2/5 of 30? Well, 2/5 of 30 is going to be half of 24, or 12, or 1 foot. Again, a little bit too much, but just take 30 divided by 5, that equals 6. 2 times 6 is equal to 12. That's going to equal 1 foot. The one that they do have, which is a little bit hard, is the 3 1/3 feet related to 40 inches. So 3 1/3 feet is equal to 3 feet is 3 times 12, or 36 inches. So 12 inches for each foot. So you're going to change feet to inches. You're going to get a bigger number. So 3 times 12 is 36. But what's 1/3 of 12? 1/3 of 12 is 12 divided by 3, or 4. Add the 36 inches plus the 4 inches. That gets you to 40 inches. They do have this answer on the next page. So 1/2 of a foot is 6 inches. 2 feet is 24 inches. I use the 1/5. They don't really use that. And I use the 4/10, and I use the 60. Numbers that they don't actually use in their answers. 3 1/3 feet is the same as 40 inches. And I think that's it. So look at their answers. 24 feet is 2 feet. 24 inches, is 2 feet. 12 inches is 1 foot. 6 inches is 1/2 of a foot. And 40 inches is the hard one. 40 inches is 3 1/3 feet. So again, the idea of this activity is really just recognition of these relationships, not so much the calculation, but the recognition. So that's activity 1. This is activity 2 from lesson 3, more about constant of proportionality. And in this activity, we do get into the details of figuring out what the constant of proportionality is and doing those calculations. And this activity is focused on centimeters and millimeters. And what's the relationship between centimeters and millimeters? It is 10 times. So you need 10 times as many millimeters, 50 millimeters, to cover the same distance in centimeters, 5 centimeters. So notice that the number of millimeters that you need is 10 times the number of centimeters, because millimeters are much smaller. So you need a lot of millimeters compared to not as many centimeters. And millimeters are 1/10 the size of centimeters, so you need 10 times as many to cover the same distance. So centimeters are larger than millimeters. They are 10 times larger. So you need fewer centimeters, 5 centimeters, to cover the same distance, 50 millimeters. So this is basically a double number line. And so you can see that the relationship is right here. It's 1/10. So to go from centimeters to millimeters, you multiply by 10. To go from millimeters to centimeters, you divide by 10, or you multiply by 1/10. So now we're going to use the convention of always setting up the left column as the x column and the right column as the y column. And you'll see why we do this in the future. We're going to go over this a whole lot of times. And the constant proportionality is going to be y divided by x. So in other words, if you have 10 millimeters, how many centimeters do you have? Well, you have 1/10 as many millimeters. So you have 1/10 of 10 is 1. So how many of these, let's just use this one. So 40 millimeters, to change that to the number of centimeters, it's 1/10 as many. So 1/10 of 40 is 4 centimeters. So 4 centimeters divided by 40 millimeters is 1/10. It is that relationship of how many of these 4s can you get into 40, or if you divide 40 up by 4, how many groups of 4 do you get? You get 10 of them. So this 4 centimeters is 1/10 of 40 millimeters. Now if you want to go the other way, if you want to figure out centimeters to millimeters, you're going to multiply by 10. So 4 times 10 is 40, 1 times 10 is 10. And we're going to go into how you set this up and how you get this in a few minutes. But we're going to start talking about the reciprocal of these factors. And so the reciprocal is also called the multiplicative inverse, because of the reciprocal of 1/10 is 10. It's 10 over 1, which is the same as 10. Well, multiplicative inverse means that any two numbers that you can multiply together to equal 1, they are by definition multiplicative inverses. So 1/10 times 10 over 1 is the same as, and you can use the commutative property and move these around. It's the same as 10 over 10 times 1 over 1. 10 over 10 is 1, so 1 times 1 is 1. And you know that 1/10 of 10 is equal to 1. So again, we're going to go over this a lot. We're going to go over this stuff a lot. So don't worry about understanding it right now, but we're going to get into this right now. All right, so the first table up here, the first thing to do is just to fill this table in and realize that how are you going from centimeters to millimeters? What are you multiplying by to get from centimeters to millimeters? Now remember, millimeters is the smaller unit. So millimeters is smaller, so you need 10 times more of them to equal the same number of centimeters. The same distance, as the centimeters. So the number of units of y, in this case y is going to be on the right side as always, is 10 times the units of x. So 9 times 10, so 9 centimeters times 10 is going to tell you how many millimeters that is. 9 times 10 is 90. 12.5 times 10 is 125. 50 times 10 is 500 millimeters. So again, millimeters is smaller, so you need 10 times more millimeters to cover that same distance as 50 centimeters. So y is equal to 10 times the number of centimeters you have. And 88 and 49 hundredths centimeters, 10 times that is 884 and 9/10 millimeters. Now notice that when you multiply by 10, you always use the same digits. So let's look at the 12 and a half for example. 12 and a half times 10, same digits, 125, 125. But what's happened to those digits is they've slid over one place value larger. So they've all slid over one place value larger to make it 125. And it shows up best in this one right here, 88 and 49 hundredths times 10. So just write 8849. And what do you do with those digits? You slide them over one place value larger. Now, many teachers will teach it as just move the decimal point. The problem with that is that the decimal point never moves. It always stays in the same place. So if you want students to understand the concept of place value, teach them that when you multiply by 10, each of these digits moves one place value larger. So 8849, 8849, but each of these digits has slid over to the left one place value or one place value larger. All right, so what is the constant of proportionality? Well, if you look at that, 90 divided by 9, so how many of these 9s do I need to get to 90? I need 10 of them. So 90 divided by 9 is 10. So y, that 90, is 10 times x, 9. So y is going to equal to 10 times x. 90 is equal to 10 times 9. 10 is equal to 10 times 1. So whatever the value of x you're given, 9, 12 and a half, 50, you multiply that value to get the value of y. You multiply the value of x times 10. So y is equal to 90 times 10, or 9, or I'm sorry, y is 90, so 90 is equal to 10 times 9. So that 90 is equal to 10 times 9, y is equal to 10 times x. Sorry about that. All right, so the next one is switching them, going from millimeters to centimeters. So if you're given the number of millimeters, how do you get the number of centimeters? Well, it's 1/10. So y in this case is going to be 1/10 of 70. So that's 7 is 1/10 of 70. 224 and 5/10 is 1/10 of 245. So notice the same digits once again, but now you're multiplying by 1/10. So each of these digits moves one place value to the right, one place value smaller. So it becomes 24 and 5/10. 4/10. So y is equal to 1/10 of 4. So 1/10 of 4 is 4/10. Y is equal to 1/10 of 699 and 1/10. So if you move each of these digits, just 6991, move them one place value smaller, which means move them one place value to the right, becomes 69 and 91 hundredths. So you need fewer centimeters. So you have to look at the problem and think, okay, I need fewer centimeters. What are you going to do? You're going to multiply the number of millimeters times 1/10 to get fewer centimeters, 10 times fewer, or 1/10 as many. So the number of units of y is 1/10 times the units of x. And here's an example right here of just writing the digits out and sliding them over one place value smaller. So that 4 slides over 1/10, one place value to 4/10. 699 and 1/10 slides over to 69 and 91 hundredths. So the decimal point stays in the same spot. The digits just slide over one place value to the right. All right, so you complete this table, and then you ask the question, what am I multiplying x by to get to y? So that y is equal to 1/10 the value of x. So 7 is 1/10 of 70. So y is 1/10 of x. So whatever value I'm given as x, I multiply that by 1/10 to tell me what y is, because y is 1/10 of x. So equals 1/10. It's going to take a while to get used to that. So how are the two constants of proportionality related to each other? Well, one constant of proportionality is 10, so you multiply, every time you see centimeters, you multiply that times 10 to get millimeters. Every time you see millimeters, you multiply that times 1/10 to get centimeters. So you're going the opposite way. So these constants of proportionality are reciprocals of each other. And that's really called the multiplicative inverse of each other. So 10 times 1/10 equals 1. The reciprocal, and teachers again will tell you just flip the fraction over. It's better stated as use the multiplicative inverse. I use 3/5 here because it shows up a little bit easier to see. The reciprocal of 3/5 is 5/3. So 3/5 times 5/3 equals 1. Use the commutative property to move these around. 3 over 3 is 1. 5 over 5 is 1. So 1 times 1 is 1. They are multiplicative inverses. So to convert from centimeters to millimeters, so now you're going from centimeters to millimeters, a large unit to a smaller unit, you're going to need a lot more of these millimeters. So you have to think, okay, I need a lot more. I'm going to multiply by 10 because I know the relationship is 10 and 1/10. So you multiply by 10, and they don't ever tell you that that's the same as dividing by 1/10. They should. So you multiply by 10, or you could divide by 1/10, because most people would never do this. I'm not going to divide by 1/10. Well, operationally, it's the same thing. Divide by 1/10 is the same as multiplying by 10, because down here, you look at it down here, it's the same idea. To convert from millimeters to centimeters, okay, I have a bunch of small units. I have a whole lot of those. Now I need to get a smaller number, so I'm going to multiply by 1/10. So you can divide by 10 or multiply by 1/10. And I drew this down here just to remind you that there are inverses, there's inverse operations, and there are multiplicative inverses. So up here, if I multiply by 10, I can use the inverse operation, which is to divide. I can divide by the multiplicative inverse, which is 1/10. So again, I can multiply by 10 or divide by 1/10. Multiply by 10 or use the inverse to divide by the multiplicative inverse, which is 1/10. Likewise, for b, I can divide by 10 or multiply by 1/10. So I can divide by 10, or I can use the multiplicative inverse, I can use the inverse operation to multiply by the multiplicative inverse, which is 1/10. So a lot of this is confusing language. It takes a lot of time to keep going over it to get used to what all of this means. So you have inverse operations, and you have multiplicative inverses, and figuring out what the constant of proportionality is, and pretty soon you just look at it as y divided by x. But what you're figuring out is how many times does x go into y. In this case it's 10 times. In this case it's 1/10. How many times does that x go into that 7? Just 1/10 times. Okay, this is activity 3 from lesson 3, more about constant proportionality. In this case, I'm going to move to using speed as that constant of proportionality. And speed is a relationship between the distance traveled and the time it takes to travel that distance. So in this example, if you walk for 4 miles and it takes you an hour to walk that 4 miles, and you are walking at a speed of 4 miles per hour. So speed is the distance related to the time. And I always think of miles per hour. It helps me remember that it's distance over time is the speed. Miles per hour is something we're all familiar with. So if I just think miles is the distance and hours is the time, that reminds me that it's distance per time or distance over time. Now for speed, it's not a fixed amount. It's depending on your speed, that relationship of distance to time is going to change. Unlike centimeters and millimeters, there's a fixed relationship between millimeters and centimeters, and that is 10 millimeters for every centimeter. But if you're going at a different speed, that relationship between distances and time is going to change. So when they give you problems like this, they're always going to include that it's traveling at a constant speed. So that's a fixed distance per amount of time. They're always going to have to tell you what one of those examples is. So we'll come back to this in just a second, but they're always going to have to fill in both columns so that you can figure out what the speed is in the problem. So 1 hour, 550 miles. They always have to give you that example. And so there's a plane traveling from New York to San Diego, and that plane is actually traveling at 550 miles in 1 hour. So that is its speed. Now I'm going to show you how to calculate that in just a second. And it goes from New York to Pittsburgh, Pennsylvania, to St. Louis, Missouri. That distance from Pittsburgh to St. Louis is 550 miles, and it took the plane 1 hour to travel that. So that's what's given in the problem. And then from St. Louis to Albuquerque, New Mexico, it takes 1 hour and 42 minutes, and we'll talk about these calculations in a few moments. And then from Albuquerque to Phoenix, that's another 330 miles. They're going to ask you to calculate the time it takes, and then finally from Phoenix to San Diego. And so they have to tell you, they have to give you one example. And so they say from Pittsburgh to St. Louis, it takes 1 hour to travel that 550 miles. So I'm going to make the time, once again, the x value, and the distance, the y value. So the constant of proportionality is that distance per this amount of time. So how many ones are there in 550 miles? Well, there's 550 of them. So this distance, this unit, 550 miles, is 550 times this 1 unit for 1 hour. So speed is the constant of proportionality. It's 550 miles divided by this 1 hour, which equals 550. So the number of units of time is always going to be 550 times the number of units of distance is always going to be 550 times this number of units of time. So the units of time in this case is 1 hour. 550 times that is going to give you the distance, 550 miles. So that constant, what you're always multiplying by, is 550. Well, another complication of this problem is you have to make a decision. Do you want everything? You have to have the time measured in all the same units. You can't have a mixture of hours and minutes. So your choice is either to change this all to minutes or change this all to hours. And so I chose to change it all to hours. So 1 hour and 42 minutes is the same as 1 7/10 hours. That calculation is down here. And they choose these numbers on purpose. You know, that 42 minutes, it's not an accident that 42 and 60 are both multiples of 6. So 42 minutes, what fraction of an hour is that 42 minutes? Well, what fraction of 60 minutes is that 42 minutes? So it's 42 out of 60. So what fraction is that? That's 6 times 7 is 42. 6 times 10 is 60. The 6 divided by 6 is equal to 1. So it simplifies to 7/10, 7/10, and then you can write that as 7/10 of an hour. And that makes sense because 1/10 of an hour, if an hour is 60 minutes, 1/10 of 60 minutes is 6 minutes. And you need 7 of those tenths. So 7 times 6, what's 7 of those tenths? 7 times 6 is equal to the 42 minutes. So it makes sense. Now you could just have simply divided 42 minutes, 42 by 60 on a calculator and gotten 7/10, but you lose all context if you do that. So you should practice just mentally going through the arithmetic, looking at the factors, simplifying it, realizing that 7/10 is the same as 7/10 written as a decimal, and then check it. I need 7 of those tenths. So 7 times 6 is 42. These problems are hard because they're trying to incorporate a lot of number sense at the same time as working through the answers. All right, so if we change this to 1 7/10 hours, so remember that it's 550 times that 1 7/10. hours. So it's for every unit in terms of in time, you need that distance is 550 times the number of units, or 550 times this 1 7/10. All right, so again, you could just multiply this with a calculator, but challenge yourselves a bit. Do it without a calculator, so 550, so that's the 1 hour, and then you're going to add that to 7/10 times 550. Well, 7/10 times 550, that's 7 times 1/10 times 550. That is the same as 7 times 55. Well, what's 7 times 55? We'll break it up into two parts. 7 times 50 is 350. You know that 7 times 5 is 35. So 7 times 50 is 350. And I just told you 7 times 5 is 35. You know that. Add them together, it's 385. All right, add that 385 to the 550. You get an answer of 935. Now, as I say it, it sounds long and hard and complicated, but just practice it, just go through it, and you're going to see it's not that bad. All right, so now 935 divided by 1 7/10. If you do that division, I thought I did that somewhere, but anyway, it doesn't look like I did. 935 divided by 1 7/10 does in fact equal 550. So you're going to reduce, you divide by 1 7/10, you're going to make this value smaller, and that is reduced down to 550 miles per 1 hour. All right, so now they say, well, what if you've traveled 330 miles? How long does it take to travel that 330 miles given this speed? So now you're going to multiply by the reciprocal of 550. So now you're going to go the other way. So you're going to multiply by 1 over 550. So 330 times 1 over 550. We'll take another look for a moment and realize that it's a fraction of 550. This 330 miles is what fraction of 550 miles? So if you wrote this as 330 over 550, it's that fraction of an hour. And where does that come from? That's 1 over 550 times this 330. So this fraction, 330 out of 550. So simplify that. So write this as 3 times 11 times 10. And this is the reason I'm choosing these numbers. And write this one as 5 times 11 times 10. The 10s cancel, the 11s cancel, and what are you left with is 3/5 of an hour. Well, 3/5 of an hour is the same as 6/10, and you can write 6/10 as a decimal, 6/10. So it takes 6/10 of an hour to travel that 350 miles. And so what's 330 divided by that 6/10? That should be 550, because this is the same constant of proportionality. So whatever value of y you have, you divide that by whatever value of x you have. It should always equal that constant, 550 in this case. Well, 330 divided by 6/10 is the same as 330 times 10/6. Think about where that comes from. 330 divided by 6/10. You multiply by the reciprocal. So you're going to use the inverse operation, and you're going to use the multiplicative inverse. So 330 times 10/6. So break that up into parts. 330, so remember I've told you before to divide by 6 first in this case. 330 divided by 6 is the same as 300 divided by 6 plus 30 divided by 6. Why? Because I know what 30 divided by 6 is. It becomes easy. And you multiply that answer by 10. Well, what's 300 divided by 6? That's 50. 30 divided by 6 is 5. 50 plus 5 is 55. Times 10 is 550. And again, I know it seems hard and long, and gee, why go through all that work? Well, the reason to go through all that work is to build up a number sense. What's going on as far as the numbers? Okay, what's the proportional? How many minutes did it take to fly between Albuquerque and Phoenix. So we did the distance, 935 miles. How many minutes is this? 6/10 of an hour. How many minutes is that? Well, 6/10 of 60. 60 minutes. 6 times 6 is 36. So the answer is going to be 36 minutes. 6/10 of 60 is 1/10 of 60 is 6. And 6 times those 6 minutes is 36 minutes. 6 times 6 minutes is 36. What is the proportional relationship represented by this table? It's miles are proportional to hours. So the number of miles you travel is proportional to the number of hours, the amount of time you travel. So the distance is proportional to the time. And Diego says the constant of proportionality is 550. Well, we know that. That's what we worked with. But Andre says, I think the constant of proportionality is 9 1/6. So do you agree with them? Explain your reasoning. What Andre chose to do is to change this time to all minutes rather than hours, 1 7/10 hours. He said, I'm going to change it to all minutes. So I'm going to change this to 102 minutes. So miles per minute. So you can think of this as 550 miles per 60 minutes instead of 1 hour. So how far or how long does it take in minutes to travel 550 miles? So how many miles per minute is that? Well, 550 divided by 60 is the same as 55 divided by 6. So you divide it by 10, divide by 10. And break this 55/6 up into two parts that are easy to calculate in your head. 54/6 plus 1/6. 54 divided by 6, you know what that is. That's one of your multiplication facts. 54 divided by 6 is 9, plus 1/6. 9 plus 1/6 is 9 1/6. So it's 9 1/6 miles per each minute. And that is equal to, that is the same as 550 miles per hour. So if you multiply this times 60, you're going to get back to this 550. You can kind of see that. 9 times 60 is 540. 1/6 of 60 is 10. 540 plus 10 gives you that 550 miles per hour. So both are correct. Again, just a ton going on in this problem. Lots of number sense. And as they are introducing to you constant of proportionality. This is the cool down activity for lesson 3. It's filling a fish tank. And so this fish tank fills at a constant rate. So you have to remember that constant rate means it's not changing. It's not speeding up or slowing down. So they have to give that to you, that it's a constant rate. How many gallons of water will be in the fish tank after 3 minutes? So here's 3 minutes. They have to give you one row, one complete row, so that you can figure out what the relationship is between these two properties. One property of the fish tank filling is the time it takes. The other property is the number of gallons that are in the tank, that get filled into the tank. And so that relationship is y divided by x. That is the constant of proportionality. So 8/10 divided by 5/10 is equal to 8/5. So I'm going to leave it as a fraction and use it as a fraction. Although you could figure out that constant of proportionality is 1 6/10, because if you double the 5/10 to 1 and you double the 8/10 to 1 6/10, you could use the constant of proportionality as 1 6/10, because 1 6/10 divided by 1 is 1 6/10. But I'm going to use 8/5 because I want to practice, and I want students to practice calculating with fractions. And so what that means is that y is 8/5 of x. So 8/10 is 8/5 of 5/10. Well, if I take 5/10 and I divide it by 5, that's 1/10. And I need 8 of those 1/10. That is 8/10. So 8/10 is 8/5 of 5/10. So if I multiply 1 times 8/5, that does equal 8/5. And 8/5 is 1 3/5. And 3/5 is equal to this 6/10. I know it seems like a lot, but it's good practice. It's good to go through those calculations. Now 3 times 8/5 is going to be 24/5. fifths. 3 times 8 is 24. And I would split the 24 up into 20 plus 4. 20 fifths is the same as 4. And now this becomes 4 and 4 fifths. And 4 and 4 fifths is the same as 4 and 8 tenths. So 4 fifths is equal to 8 tenths. And finally, if you go the other way, and this is really the reason I wanted to use the fraction to show you that they choose these numbers on purpose. It's not by accident that 40 is a multiple of 8. So if you go the other way, if you have the number of gallons and you want to figure out the time, you're going to multiply by the reciprocal of 8 fifths, which is 5 eighths. So 40 times 5 eighths, 40 divided by 8 is 5. And then 5 times 5 gives you that answer of 25. So it makes sense. 40 divided by 8 is equal to 5. That's 1/8 of 40. And you want 5 of those 1/8. And that is equal to 5 times 5 is this 25. So 5/8 of 40 right here is equal to 25. Once again, 40 divided by 8 is 5. 5 times 5 is 25. 40 divided by 8, that 5 is 1/8, and you need 5 of those 1/8. 5 times 5 is 25. All right, so this is the fish tank. This is the cool down. And practice using the constant proportionality as a fraction, and then use it as a decimal. Go back and forth. Build some skill in doing that. Okay, this is the summary for lesson 3. And in this summary, they look at a bug that's crawling on a sidewalk. So that's the context of this problem. So picture a bug crawling on a sidewalk. And so how long does it take that bug to travel 3/2 centimeters? So 1 1/2 centimeters. How long does it take the bug to travel that? It takes 1 second to travel that far. It takes 2/3 of a second to travel 1 centimeter. So this is a shorter distance, and so it takes a shorter time. So what's the constant of proportionality? What's the bug's time per centimeters? So it's y divided by x, so it's 1 divided by 3/2. Well, 1 divided by 3/2 is the same as 1 times, so you use the inverse operation and you multiply by the multiplicative inverse. So what's the multiplicative inverse of 3/2? It is 2/3. So 3/2 times 2/3 is equal to 1. So 1 is 2/3 of 3/2. So y equals 2/3 of 3/2. You can also get it from this next row. 2/3 divided by 1 is 2/3. 2/3 divided by 1 is equal to 2/3. You can get it from the third row. 2 divided by 3 is also 2/3. So now if you go back to these and just say this to yourselves, it starts to make sense. 1 is 2/3 of 3/2. Now think about that for a little bit. 1 is 2/2. That's 2/3 of 3/2. 2/3 is 2/3 of 1. That's not a surprise. And 2 is 2/3 of 3. So if you take 3 and you divide it into 3 equal parts, 2 of those parts is 2. 2 is 2/3 of 3. And finally, the last one, 2/3 of 10 is 20/3. So 2 times 10 is 20. 20 divided by 3 is 20/3. They don't simplify that at all, so we just leave it as 20/3. All right, so that's the pace. How far is this bug traveling, or how long does it take this bug to travel 1 centimeter? It takes 2/3 of a second. That's its pace. 2/3 seconds per centimeter. So every centimeter walked takes 2/3 of a second. Now, what if you asked the opposite question, which is, how far does the bug go in 1 second? So instead of looking at how long does it take the bug to travel 1 centimeter, how many centimeters does the bug travel in 1 second? That's its speed. That's this table. So in 1 second, that bug travels 3/2 centimeters. So what's the constant of proportionality? It's 3/2 divided by 1, which is 3/2. Now, if the bug travels for 2/3 of a second, how far is the bug gone? This is the inverse, multiplicative inverse, or multiply by the reciprocal. So 2/3 times that same 3/2 equals 1. So that bug travels in 2/3 of a second. That bug travels 1 centimeter. Well, what about 2 seconds? How far does that bug go in 2 seconds? It goes 3/2 of 2 is going to equal 3 centimeters. So the number of centimeters is 3/2 times the number of seconds. So it's a larger, the unit of centimeters is larger than the unit of seconds in this problem. And so 20/3 seconds, what's 3/2 of 20/3? Well, that is equal to half of 20/3 is 10/3, and 3 times 10/3 is 10. So 3/2 of 20/3 is equal to 10. So you just multiply, the 3's cancel out, and 20 divided by that 2 right there is equal to 10. So this is the bug's speed, centimeters per second. So how far does the bug go in 1 second? It goes 3/2 centimeters. So every second the bug travels, it travels 3/2 of a centimeter, 3/2 centimeters. That is its speed. So that is the distance, centimeters per time, seconds. Now here's a drawing of the same thing. How long does it take the bug to travel 1 centimeter? So this is distance, 1 centimeter. How long does it take? It takes 2/3 of a second. This is 1/3 of a second. This is 2/3 of a second. So how long does it take to travel 1 centimeter versus how far does that bug travel in 1 second? So this is how far it travels in a second. So now if it travels 2/3, if it takes 2/3 of a second to travel 1 centimeter, so now it's going to go farther to get the 2/3 seconds up to 1 second. So how far does it travel? It travels farther than 1 centimeter because it's more than this 2/3 seconds, and it's 3/2 centimeters. All right, so try to say this briefly. How long does it take to travel 1 centimeter? It takes 2/3 of a second. That's its pace. How far does it travel in 1 second? It takes 3/2, or it travels 3/2 centimeters in that 1 second. That is the bug's speed. These are hard things. Distinguishing between speed and pace it just takes a long time. So pace is the amount of time it takes to travel a certain distance. So 2/3 seconds to travel 1 centimeter. And speed is the amount of distance traveled in a certain amount of time. So 3/2 centimeters in 1 second, per 1 second. This is distance per time. That's speed. Same as miles, distance per hour, time. Centimeters per second. Miles, which is a distance, per time, per hour, which is a time. This is practice problem number 1 from lesson 3. And this is a tough one. There's a lot of stuff that they're putting into this problem, a lot of number sense kinds of things. So it says that Noah is running a portion of a marathon at a constant speed of 6 miles per hour. So that is his constant of proportionality, 6 miles for every hour. So if we just go through and do the calculations without trying to think of the drawing or think of what it means too much, let's see what we get. So he runs 6 miles in 1 hour. That's 1 times 6 is equal to the 6 miles. And notice if you go the other way, the number of units for miles is 6 times the number of units for hours. So if you're given 6 miles, then you're going to divide that 6 to get the units of hours. So the units of hours is 1/6 the units of miles. So the units of miles is 6 times the units of hours. So 1/2 times that 6 is equal to 3 miles. And that makes sense. If it takes 1 hour to run 6 miles, in a half an hour he runs 3 miles. Well, what about 1 1/3? 1 1/3 times 6 is the same as 4/3 times 6. Well, 4/3 times 6 can be a little bit tough. It's 4/3 times 6. You can write 6 as 2 times 3. These 3's cancel out, and 4 times 2 will give you an answer of 8 miles. And that makes sense. If you're running more than a mile, so you're running more than 6 miles, you're running 1/3 of an hour farther. Well, 1/3 of 6 is equal to 2. It's right here. 1/3 of 6 is equal to 2. So it's 6 miles for the 1 hour, and then 1/3 of 6, or 1/3 of an hour, gets you 2 more miles. So that's 6 plus 2 is equal to 8. If you now go the other way, so remember you're going to divide by 6 to figure out the units in hours. So now you've run 1.5 miles. How long did it take you to run that 1.5 miles? Well, it took you less than an hour, because it takes an hour to run 6 miles, but you only ran 1.5 miles. And 1.5 is the same as 3/2. So this is 3/2 out of 6 miles. Well, what's 3/2 times 1/6? They're divided by 6. 3/2 times 1/6 is 3/2 times 1/6. So that's 2 times 3. These 3's cancel, and you're left with 1/4. So for this one, let's take a look at this drawing and see if we can't make sense out of this. So I drew an hour here. 60 minutes is an hour. And that's also equal to 6 miles, because you run 6 miles in 1 hour. Well, how far do you run? How long does it take you to run 1 mile? Well, it takes 10 minutes, because 60 minutes divided by 6 miles is 10 minutes per mile. So in 10 minutes, you run 1 mile. In 20 minutes, you run 2 miles. 30 minutes, 3 miles. 40 minutes, 4 miles. And 50 minutes, 5 miles. 60 minutes, 6 miles. So in this problem, you run for 1.5 miles. So that 1 mile takes this 10 minutes. Then you run another half mile. Well, that half mile takes 5 minutes. So it's 10 minutes plus these 5 minutes is equal to 15 minutes. And 15 minutes is 1/4 of an hour. So this does make sense. And here's a little bit more of the same calculation up here, expanded out. But let's say that now you run 9 miles. Well, that's more than an hour. And that's 3 miles farther than an hour. And we figured out up here it takes, for 3 miles, it takes a half an hour. So this is going to be 1 hour plus another 1/2 of an hour. So this is going to be 3/2 hours, or 1.5 hours. So 1/6 of 9 is 1/6 times 9 is equal to 9/6. And 9/6 simplifies to 3/2. And 3/2 is the same as 1.5 hours. And that makes sense. You run for 9 miles, and you run 6 miles, that's 1 hour, and another 3 miles, that's another 30 minutes, or a half an hour. So 3/2 hours is 1 1/2 hours. And the last one, you run for 4.5 miles. How long does that take you? Well, it's less than an hour. And 4.5 is the same as 9/2 miles. And 9/2 divided by 6. Remember, you're going to divide by 6 to get back to the units in hours. Or it's the same as multiplying times 1/6. So 9/2 times 1/6 is equal to 9/12. And 9/12 right here. 9/2 times 1/6. 9 is 3 times 3. 12 is 3 times 2 times 2. These 3's cancel out, and that gives you an answer of 3/4 of an hour. So 9/2 over 6 is the same as 3/4 of an hour. 3/4 of 6 miles. In this case, it's 3/4 of an hour, because that 6 miles is the same as that 1 hour. Now remember, up here we figured out that this half of a mile is 5 minutes. We just did that right here. So this was 10 minutes plus another half of a mile got you another 5 minutes. So that half of a mile right there is equal to 5 minutes. What's 4 miles equal to? So 4 miles is 2/3 of 6. And 2/3 of an hour then is equal to 40 minutes. So this is 1/3 of an hour here and 2/3 of an hour here. That's 40 minutes plus another 5 minutes gets you to 45 minutes. That is equal to 3/4 of an hour. This is tough stuff. So I drew this out here. So 4.5 is the same as 9/2. 9/2 out of 6. Not 9/2 of 6. It's 9/2 out of 6. So it's 9/2 sixths. That's 1/6 of 9/2. So you multiply that out and you get 3/4. So then just write this as a fraction. 4.5 miles out of 6 miles. So split this out into 4 out of 6. 4 miles out of 6 miles is 2/3 of an hour. So remember, you're dividing by that 4 by 6 to change it to the units of hours. So 4 divided by 6 is going to give you 2/3 of an hour. And 2/3 of an hour is 20 minutes. 2/3 of 60. 60 divided by 3 is 20. 2 times that 20 is going to get you to 40 minutes. But what about that last half of a mile? How long did that take you? Well, you start running and you think you're going to run 6 miles, but you only run this far. You only run 1/2 of a mile. So if this whole rectangle represents 1 mile, you only ran 1/2 of a mile. But there's 6 of these in an hour. So there's 6 of these rectangles an hour. That makes 12 1/2s in an hour. So that means that this 1/2 is 1/12 of this hour. It's 1/12 of 6 miles. So 1/12 of 60 minutes is equal to 5 minutes. This is kind of tough, but it makes sense. The more you look at it, it makes sense. Each one of these rectangles represents a mile. And you set out, you start to run, you want to run for 6 miles, but you only get this far. You only get a half a mile into it. And so that 1/2 of a mile out of the total of 6 miles is 1/12 the distance that you plan to run. That is just equal to 5 minutes. You start out, you're going to run for 60 minutes, and something happens. You only run for 5 minutes. So 1/12 of 60 is equal to 5 minutes. So add that 5 minutes to the 40 minutes. That's a total of 45 minutes, which is 3/4 of an hour. All of this stuff is hard. You just have to continue to try to think through it. This is practice problem number 2. And in this practice problem, it's more on constant proportionality and more on this idea of, this is comparing meters to kilometers. So this idea that meters are small compared to kilometers. So to figure out an equal number of kilometers, you need a whole bunch of meters. Or to figure out the equal number of meters, you need a fraction of kilometers. So meters are small, so you need a bunch of them. Kilometers are big, so you don't need as many. So the number of units of kilometers is going to be 1/1000th the number of units of meters, because kilometers are 1,000 times larger. So you only need 1/1000th the number of kilometers than you need for the number of meters. So 1,000 meters equals 1 kilometer. So the constant of proportionality is 1 divided by 1,000. So I need a whole bunch of meters to equal 1 kilometer. So I'm going to multiply that 1,000 meters by 1/1000th, same as dividing by 1,000. So 1,000 meters times 1/1000th equals 1 kilometer. 250 meters times 1/1000th. So you're dividing by 1,000. So you're making this much smaller. That's the number of kilometers. And when you divide by 1,000, remember, just slide the digits. In this case, you're going to slide the digits 3 place values to the right. You're going to keep sliding them to the right until you get to 250 thousandths kilometers. 12 meters, 1/1000th of 12 is 12 thousandths. 1/1000th times 12. So you're going to divide that 12 by 1,000 or multiply by 1/1,000. So you only need a fraction of a kilometer to equal 12 meters. You need a really tiny fraction of a kilometer to equal 1 meter. You need 1/1000th of a meter to equal 1 kilometer. So 1 times 1/1000th equals 1,000. This is the constant of proportionality. 1/1000th, same as up here, 1/1000th. To go the other way, to go from kilometers to meters, you multiply the number of kilometers by 1,000, because you need a whole bunch of meters to equal 1 kilometer. So you need 1,000 meters to equal 1 kilometer. So you're given 1 kilometer, multiply by 1,000, gives you 1,000 meters. So the constant of proportionality is 1,000 divided by 1, or 1,000 meters per kilometer, or just 1,000. So 5 times 1,000, if you have 5 kilometers, then 5 times that 1,000 is going to give you 5,000 meters. And again, if you're figuring out the number of meters you need 1,000 times the number of kilometers. 20 kilometers, you need 1,000 times that. You need 20,000 meters to equal that same distance. And if you only have 3/10 of a kilometer, you need 1,000 times that 3/10, which is equal to 300. So again, if you multiply by 1,000, you slide each digit to the left, 3 place values. And so that 3/10 is going to end up at 300. So the constant of proportionality tells us to divide meters by 1,000, to divide the number of meters by 1,000, or multiply by 1/1000, so 1/1000th, because you're going to make this number a lot smaller to get to kilometers. And the constant of proportionality for the table on the right tells us to multiply kilometers by 1,000 or divide by 1,000th to get to the number of meters. So you're going to multiply by 1,000. So you're going to make this number a lot larger, which is the same, by the way, as dividing by 1/1000th. So if you're dividing by a really tiny number, you're going to get a huge amount in the end. And what's the relationship between these two constants of proportionality? They are reciprocals, also known as multiplicative inverses. 1,000 times 1/1000 equals 1. 1,000 times 1,000th equals 1. So to go from kilometers to meters, you need a whole bunch of meters, so you're going to multiply it by 1,000. To go from meters to kilometers, you just need a fraction. You just need 1/1000th of the number of meters to tell you how many kilometers you need. So you're going to divide by 1,000. This is practice problem number 3. And in practice problem number 3, Jada and Lynn are comparing inches and feet. And Jada wants to use a constant of proportionality of 12. Lynn says the constant of proportionality is 1/12. So do you agree with either one of them, or are both of them correct? So for Jada, she's going to go from feet to inches, because she's going to use a constant of proportionality of 12. So remember that inches are smaller, so you have to have a larger number of inches to equal the number of feet to cover the same distance. So 1 foot is equal to 12 inches. So you have to increase this 1 times 12 to figure out the number of inches. So the constant of proportionality is 12. If you're given a number of feet, you multiply that number times 12 to figure out the number of inches. So y divided by x is 12 divided by 1 is equal to 12. So the constant of proportionality to go from feet to inches is 12. You multiply by 12. On the other hand, Lynn says, I want to go from inches to feet because she's going to divide by 12. So once again, remember that the number of feet is going to be 1/12 the number of inches. So 12 times 1/12 is 1 foot. So if you have 12 inches times 1/12, the constant of proportionality, that equals 1 foot. So the constant of proportionality is 1 divided by 12. So 1 divided by 12 is 1/12. So if you have 12 inches times 1/12, that is equal to 1 foot. And so both of them are correct. The constant proportionality for Jada is correct. It's 12. It's 12. And the constant proportion for Lynn, she's also correct. It's 1/12. And notice that they are reciprocals. 12 times 1/12 equals 1. It's going to go one way, feet to inches, you multiply by 12. To go the other way, inches to feet, you divide by 12, or you multiply by 1/12, the reciprocal. This is practice problem number 4. And in practice problem number 4, the area of the Mojave Desert is 25,000 square miles. On a map, a scale drawing of the Mojave Desert has an area of 10 square inches. So what is the scale on the map? So you're going from 25,000 to 10. So what's that scale factor? How do you go from 25,000 to 10? Well, 25,000 to 10. If I want to keep the 10 and I want to get rid of the 25,000, I can multiply by 10 divided by 25,000. And that's the same as 1 over 2,500. So 10 over 25,000 is the same as 1 over 2,500. So this becomes the scale factor for the area. 1 over 2,500 times 25,000 gets you to this 10 square inches. So the scale factor for the area is 1 over 2,500. So what's the scale factor for the length then? Well, that has to be the square root of the scale factor for the area. So what's the square root of 1 over 2,500? Now they pick this number for a reason, because you can kind of figure that out just by looking at the numbers. So write 2,500 as 25 times 100. That's 25 times this 100, 25 times 100. And you can figure out what the square root of 25 is and what the square root of 100 is. Just ask yourself, what number times itself equals 25? Well, that's 5. 5 times 5 is 25. And what number times itself equals 100? That's 10. 10 times 10 is 100. So that means that the square root of 25 is that 5, and the square root of 100 is that 10. So 1 over 5 times 10, square root of 25 is 5, square root of 100 is 10. 1 over 5 times 10 is 1 over 50. So the scale factor for the length is 1/50th. And the scale is the reciprocal of the scale factor. So every 1 inch is equal to 50 miles. So every 1 inch is equal to 50 miles. And that is the scale for this map. All right, this is practice problem number 5. And in practice problem number 5, it says, which of these scales is equivalent to the scale of 1 centimeter to 5 kilometers? Select all that apply. So what you want to do is get all of the values on the left to 1 centimeter, and through that multiplication, through that conversion, then you multiply the values on the right by that same value, by that same factor, and see if it goes to 5 kilometers. So for example, 3 centimeters to 15 kilometers. So I'm going to get that 3 centimeters to 1 centimeter. So you divide by 3. And 15 divided by 3 is equal to 5. And sure enough, 1 centimeter to 5 kilometers is the same scale as 3 centimeters to 15 kilometers. So A works. Now you do the same thing for B. So now you have 1 millimeter, remember, it's 1/10 of a centimeter. So to go from 1 millimeter, you have to make this value smaller by 1/10 because centimeters are bigger. So 1/10 of a centimeter is the same as 1 millimeter. And that's compared to 150 kilometers. All right, so now get this to 1 centimeter by multiplying by 10. So 150 kilometers times 10 is 1,500 kilometers. So this scale is not correct. So B does not work. C, 5 centimeters. So you get this 5 centimeters to 1 centimeter. So you divide by 5, and that means 1 kilometer divided by 5 is 1/5 of a kilometer. 1/5 of a kilometer is 2/10 kilometers. So it's 1 centimeter to 2/10 of a kilometer. So that one does not work. And you could tell from here that it wasn't going to work, but you just carry it all the way through, and that does not work. D, 5 millimeters is the same as 5/10 of a centimeter. So 5/10 of a centimeter compared to 2.5 kilometers. So if you double the number of centimeters to 1 centimeter, double the number of kilometers, 2.5 to 5 kilometers, that is the correct scale. So it's 1 centimeter to 5 kilometers. So D does work. And E, a little bit tougher. I'm going to change this 500 meters to kilometers. Well, 500 meters is 1/2 of a kilometer. 500, 1/2 of 1,000 is 500. So 1/2 of a kilometer is 5/10 of a kilometer. So 500 meters to 5/10 of a kilometer, or 1/2 of a kilometer. So now I can write this as, I combined a couple of steps here. 1 millimeter is the same as 1/10 of a centimeter. So 1/10 of a centimeter compared to 1/2 of a kilometer. 500 meters, 1/2 of a kilometer, 1 millimeter, 1/10 of a centimeter. All right, so now get this to 1 centimeter by multiplying by 10. And so what happens to the kilometers? You multiply by 10, that becomes 5 kilometers. So that scale does work. It is the scale, the same scale as 1 centimeter to 5 kilometers. So the answers are A, D, and E. This is practice problem number 6 for lesson 3. And in practice problem number 6, it asks, which of these ovals does not fit? So which one is not like the others? And so what I did is I looked at the ratio of the widths of the inner oval to the outer oval. So I counted the number of units for the width of the inner oval and compared that to the number of units of the width of the outer oval. For L, that is 3 units, 1, 2, 3, compared to 5 units, 1, 2, 3, 4, 5. So the inner oval to the outer oval is 3 to 5. For M, the inner oval to the outer oval is 4 to 10. 1, 2, 3, 4. And if you counted these all up, you get 10. 4 to 10 is the same as 2/5, not 3/5. So these two are different. So the question then is just, which one, is this going to be like this one, like M, or is it going to be like L? And so the ratio for N is 9 units. So if you count the number of units here, you get 9. And if you count the number of units all the way across, you get 15. So 9 out of 15 is the same as 3 times 3 out of 3 times 5. The 3's cancel, and you're left with 3/5. So this ratio for N is of the inner oval to the outer oval is 3 to 5. For L, it's 3 to 5. And the one that does not fit is M, because that ratio is 2 to 5. So the answer is M. That one does not